Hello, everyone, and thank you for taking the time to review our mission for national and international security optimization. Our teams have been working on these solutions for years and leading the way on integrations that are now primed for the tactical edge. This video is to highlight how Vantiq's platform allows for the next generation interoperability for machine-to-machine communications, human-machine teaming, and goal-based autonomy protected by zero trust and specialized quantum encryption. This software enables the Force from the famous movie Star Wars to become a reality by allowing operators to control the world around them in various ways that can adapt to each situation based on real-time information from the integrated sensors and assets on the highly encrypted network. The more sensors and predefined protocol that are layered into the architecture, the more the end users can activate immediately. This includes autonomous responses by drones and other robotics based on real-time sensor data. We can make nearly any practical outcome you can imagine work in real time with systems and equipment that would not normally communicate. This allows for unparalleled interoperability for offensive and defensive swarming, along with resupply and sustainability of any mission. We are going to introduce you to a live viewing of Vantiq software and the art of the possible as we continue to advance. John, would you like to tell everyone about your background for medical and tactical solutions, sir?
Sure. Hello, I'm John Dominguez. I'm a former Army Special Operations medic. Currently, I serve as the president of the Special Operations Medical Association. I've recently been awarded the 8th Army Medical Department Honorary Regimental Sergeant Major position. And I've conducted in my career 20 operations in 27 different countries. And now I'm here with Vantiq in order to help push this initiative forward.
We really appreciate your time, sir, and thank you for contributing to this mission. Jim, would you like to introduce Vantiq and your team along with leading into the presentation, sir?
Yep, absolutely. Thank you, Jordan. Thank you, John. Yeah, so thank you for joining our session. And on the call today, we have J.T. Jarvis, who is a former Navy Chief Warrant Officer, also a crypto officer, and after serving our great Navy, he's been in the industry, and I've known him now for many years. So JT is part of my team helping us out with federal and public sector related sales markets. Also on the call is Brett Rudenstein, and Brett's going to be our next primary speaker and showing the technology. So Brett, I'm going to hand it over to you. Give a little bit of your background if you don't mind, and then go ahead and get us underway.
Sure. Thanks, Jim. Again, I'm Brett Rudenstein, Vice President of Solutions Architecture. I've been at Vantiq now for about 7 years, and I've spent the last 25 plus years or so in various forms of application lifecycle management, big data, embarrassingly parallel applications, or what you might consider grid-style computing, as well as stream analytics. And my primary responsibility is to help our customers not only understand our technology, how it applies within their mission spaces, but as well to help them implement those technologies as well. With that, I think what I'll do is I'll do a couple of just quick slides as background as to what the platform is, and then we'll jump into a live demonstration. And if there are any questions as we go along, please feel free to jump in. But okay, so let's see here. I'm going to share my screen. And Jim or somebody, if you could just confirm that you are seeing the slides.
Yes, sir.
Yeah, you're good.
And so really, I'll try to keep the slide portion of this relatively brief. But what Vantiq is it is a platform for identifying situations of interest by orchestrating real-time events. You could say that Vantiq sits at the intersection of streaming sources, other systems, and very specifically the individuals or people that have to interact with those streams to arrive at specific outcomes. In a business context, it's a business outcome. In a medical context, it's a patient outcome. In a military context, it's a mission outcome. And the whole goal is to give you the ability to effectively sense, analyze, and act on those situations of interest. I'm going to come back to this slide in just a moment, but what I want to talk about is sort of some of the underpinnings, some of the architectural decisions made in the platform to help you understand how it supports widely distributed, whether they're geographically distributed, decentralized environments with the ability to federate when necessary. So the first thing is to understand is that the Vantiq platform is built entirely upon an event-driven framework. So it is built on an RX, or what you might call a reactive architecture. It is designed, excuse me, as an event-driven platform to separate messages from business logic. But as an asynchronous messaging platform, it is designed for the velocity, the variety, and the volume of real-time events and handling those events in real time that are necessary for mission-critical applications. The second thing that's really critical about the platform is that it has all of what I will call mission-critical attributes of applications built in. And those are, of course, the ilities of software applications, right? Reliability, availability, scalability, securability, and so forth. When you think about scalability, we traditionally think in terms of scale as horizontal and vertical scale. Vantiq adds a third dimension of scale in that it is architecturally peer-to-peer based. This means that the runtime, whether you're running on we'll say Big Iron or something as small as a Raspberry Pi, is fundamentally the exact same runtime. They are architecturally peers. They all run autonomously. They do not need dial back to a master location or a central location. However, they do have the ability as peers to communicate with each other, to pass status along to one another, or pass parameters to each other with the right permission set and, of course, with the right connectivity. And what this means is that in those connected environments, you can run a remote command across the infrastructure. You could run a remote query across the infrastructure, of course, distributed messaging, and so forth. And then the last thing is that Vantiq applications are collaborative, that humans are a critical aspect of the decision-making process. And you can think of it in terms of when a situation of interest is identified, something that typically represents an opportunity or a threat to an organization. Well, you've got to be able to capitalize on those opportunities or mitigate those threats. And in each instance, in asynchronous systems, since there's no predefined order, whoever the recipient of a current message is, has to be able to take the next best real-time action. And that action may cause another downstream recipient to take a different action, and so forth, until you get closer or the best possible outcome, business outcome, mission outcome, patient outcome, et cetera, from those streams of data. And so that is what the Vantiq platform is sort of encapsulated, or I should say the attributes that it encapsulates to support this idea of sensing, analyzing, and acting. And so I'll touch on these last 3 points for just a moment, and then we'll get into a live demonstration. When we talk about sensing, we're talking about the ability to bring data into the Vantiq platform. This also applies to egress, so data can come into the platform. It doesn't just come into a black box. It can then be rerouted outside of the platform to other systems and other services. Out of the box, we support a number of popular protocols. We, of course, have our own built-in dynamic event broker. So we've got SDKs and REST APIs and WebSocket interfaces. But we'll also listen to the popular ones, MQTT, Kafka, AMQP. We have an enterprise connector framework that allow you to connect to other things, for example, UDP, TCP, et cetera. The point is that there's always a way to bring data into the platform, and it's highly customizable, as well as get data out of the platform. But then the question becomes, why do we bring data into the platform to begin with? And that is for the situational awareness. Once data arrives, it can be analyzed into those situations of interest, again, into those things that represent opportunities or threats. And we use these activity patterns, these patterns that you see on the left-hand side. These are the sort of no-code building blocks of building a real-time application where you drag and drop the various streams of data and the kinds of manipulation that you want to do to the data. So contextualization, enrichment, enhancement, aggregation, and things of that nature are all built in, and they all encapsulate those mission critical attributes. So everything that you build in Vantiq automatically inherits those reliability, scalability, availability, and so forth. Once you've identified the situation of interest, however, it's not good enough to just simply send a message, there is an issue. Here is your issue. You have to be able to act upon that issue. And so we've also employed a special set of collaborative activity patterns that effectively allow you to do the first two things, to sense and analyze, but in context of a given problem. And this allows you to constantly monitor the stream of events in the situation at hand until you get to that best outcome that is possible from those streams of data. Vantiq also includes a number of other capabilities. As I mentioned, it's federated. There's a number of development tools, not only for handling real-time streams of data, but also for building complex UIs and interactions, both web and mobile, and an entire operational environment that allows you to understand and monitor the environment, as well as perform tests and partition applications into pieces and deploy those to those individual locations. So I'll stop the presentation part of this here, and we'll jump into a demonstration. Jim or anyone else, if you have anything you want to add before I switch over to the demo portion.
No, please continue, sir.
All right, so I'm going to show an example of an application. This was modeled after one of our oil and gas customers. I think it'll give you a sense of the different kinds of real-time actions that we're able to take in. Some of these are sensor-based, some of these are historical-based, and the ability to seamlessly fuse streams of data together. The first thing that you're looking at on the screen here is an area monitoring the output of various well production. And the main goal of this is to simply monitor that the amount of oil produced is the amount of oil collected, and looking for any anomalies in that particular data. Other things that are really important that have to do with either safety or security are various kinds of perimeter checks and things of that nature. For example, one of the common things to look for is deterioration of the pipelines themselves. And so one of the things that will commonly happen in an automated fashion is requests to inspect specific parts. You can almost think of these as routines. And so what you'll see pop up in this issues section here in just a moment is that inspection request. And so an inspection request goes out at the same time I've received a mobile notification on my mobile phone. And so you can see there's been a dispatch request here on my mobile phone over here on the right, and you can see any information about where the location of that actually happens to be. Now, what this does is it sends out an automated request for a drone inspection of the various pipeline area. And so once the drone goes out, the drone is outfitted with a vision-based capability and 5G capability. So it not only does it know where it is, but it also has an engine on it that can identify specific kinds of situations of interest. In this particular case, it looks for things like dead vegetation, which would indicate an oil leak. And it will also look for things like overvegetation, which might indicate a water leak and potentially can damage pipes. So you've just seen on the screen a second notification has come in, which is the pipeline overgrowth alert. I'm going to click over here on the link here, and you'll see exactly what occurred, which is that the drone went out and started monitoring this particular section. So whether this happens to be monitoring the pipeline, but of course this could be monitoring security, this could be monitoring, doing surveillance on a particular perimeter or fence or otherwise. And what you'll see is that it's looking for those specific indicators. And so in just a moment here in the video, you'll see that it identifies either the dead vegetation or the pipeline overgrowth. In this case, you see the pipeline overgrowth being identified. Now, because the drone has GPS on it and it knows where it's seeing these specific things, when the drone identifies those, it also picks up the location. So when crews or personnel have to be dispatched to the area for investigation, it is marked in geo and 2D spherical location the explicit geo coordinates of those events. Now, of course, the crews can be monitored, their geolocations, or the soldiers deployed to a particular location, whatever that happens to be, each of those things can be monitored in real time as the situation unfolds, as it progresses, and as you hopefully get closer to the ideal outcome of the mission or whatever it happens to be. The second thing that we'll take a look at is the actual facility itself. So here you can see this is now the refinery itself. And you can see there are a number of different kinds of sensors. So one thing that Vantiq is particularly good at is this notion of doing something called sensor fusion, which is the ability to take different streams of data from different devices, different manufacturers, an entirely different suite of sensors, if you will, and combine them together for situational awareness. In other words, each one on its own may not mean anything, but their combined sensor input represents those situations of interest. For example, in this case, we have we've got about 10 different services being represented here. There's a local weather service, there's an actual on-the-ground environmental sensor doing wind speed and direction. You have leak detection here. This leak is not a liquid-based leak, this is pressurized gas leak. And so these sensors, these ones here that you see with this little acoustic symbol, these are acoustic sensors. They're looking for, again, pressurized gas leaks. And in this particular case, they listen at the ultrasonic level for the hiss, even an inaudible hiss to the human ear of a leak of some kind. And that could be monetary in the form of, say, compressed air. It could be much more dangerous in the form of, say, methane gas or a particular kind of gas that might be more flammable. And so one of the things that becomes interesting is when you start to combine the different streams of data together. For example, if I combine the sensing of a specific kind of pressurized leak against wind speed, we can then make determinations as to how dangerous, even if it is methane, if it's in an outdoor area, as to whether or not that methane is likely to be dispersed much faster and be less dangerous, or if there's no wind speed, a much more volatile and much more dangerous situation. Fire, of course, is being detected from traditional sensing techniques, smoke detectors, heat-based detectors, but also in this case being detected by vision. And then you see this number of people jumping around here. And the reason this number is jumping around a bit is because these are the number of not only people based on either connectivity to Wi-Fi and hotspots, connectivity through mobile devices, but the number jumps around based on the number of people in front of cameras. So for example, if I click on this camera here, you'll see that there are a couple of people, once the video loads here, a couple of people in the camera's lens. Now, a few things that are worth pointing out. Yes, it is a video playing in a loop in the background, but the detections, the green detections are not part of the video. So they are being laid on in real time as the system identifies those. And what Vantiq is doing underneath the covers is taking each one of those inferences and converting it into 2D spherical coordinates. So this is really interesting because we have a camera with no specific GPS positional information. We have XY coordinates from these individuals, and we can take that and translate that into a location, a specific location on the map. So if you take a look at these three individuals, they're forming this sort of triangular shape, two gentlemen here in the front and one in the back. And if you look on the map here, as I zoom in, based on this camera's direction, we see those same two people in the front and one in the back. So it is mapping their location into physical coordinate space. This becomes incredibly important as it pertains to real-time situations of interest, because we'll need to know where these people are in the event that there's various kinds of evacuation criteria and so forth. So the next thing that we're going to take a look at is what happens when we start gaining or having situations of interest. What happens when the situation on the ground changes? So what you're going to see here in just a moment is you'll see, let me bring up my mobile phone, is you'll see that one of the leak detectors just went off. You can see which one it was. You also notice on my mobile phone, there's a pipe leak sensor that was triggered. So what the system has just done is one of our pieces of equipment here, specifically this piece of equipment, has gone into alarm state. it is now hearing the hiss of the pressurized gas leak. And what it's done is it's gone out and it's notified the right individual with the right skill set in the right georadius who can actually handle this specific issue. And it's gone ahead and it's sent them a notification on the mobile phone. So they are now prompted to investigate. They have a number of things that they can do. They can raise the alarm status. They can investigate. They can start triaging that situation of interest. Of course, these things don't necessarily stay static. Now, at the same time that this occurred, the system, as you know, sent out that mobile alert. And when it sent out the mobile alert, it was able to identify not only the individual who were responsible, but it was able to start a conversation. So one of the things Vantiq is able to do is incorporate generative AI and not only allow people to interact with generative AI at a prompt level where a human can ask a question, but Vantiq allows real-time streams of data to effectively make a facility or make a base or make a city come alive by initiating the conversation. If I kind of jump back to the mobile here, you can see that it started the conversation. This isn't starting with the human, rather the assistant said, a new issue was just identified at the date to 2023-11-14 at the Acme refinery. Appropriate personnel have been notified of a pressurized gas leak. Type of gas at this point in time is unknown. Well, I can also now start interacting with this. So I could say something like, how many people are at the facility? And by interacting with the situation or with the building now has its own contextual awareness of what's going on at a given moment in time. And so the system will come back in a moment and it will report what it knows about the current situation on the ground. So we'll give that just a moment here. The other thing is, of course, the generative AI engine that you use can be faster or slower depending on where it is, whether it's on premises, whether it's in the cloud, and so forth. And so these kinds of interactions can be highly tailored and highly customized. At the same time, by the way, well, there it is. So it's come back. It says there are currently 29 people at the Acme refinery. At the same time, what if the situation evolves? What if things change? What if that gas then ignited and became a fire? So one of the things that you'll see, I'm going to go ahead and trigger the fire in this particular case, but you'll notice it doesn't then need the human to ask another question. The building, as I mentioned before, effectively has the ability to speak for itself. So I want to go ahead and click on this here. This will just basically simulate that fire condition. And if you look back on my mobile, you'll notice the mobile, the 3 dots have appeared. The building is already speaking back. So without the user sending a prompt back into the environment, the building is speaking back. So this allows a multi-way conversation as to what's going on. So this time it says the status of the ongoing issue has changed. There's an update. The new issue is a fire. There's a methane ignition. This was caused by methane gas. Appropriate personnel have been notified. And then it tells you the evacuation conditions. It says only individuals in Sector 1 should evacuate. Others should stay alert as the situation progresses. So it's basically pulling from a semantic index of understanding about what the criteria is for partial and full evacuation. How many people are near the fire? And so it's worth pointing out that adding this conversational element is all built in these low-code patterns as well. And so it was a matter of only a couple of hours of incorporating something like this into the environment. So here you can see it says there are currently 3 people near the fire at the Acme refinery facility. And so we can continue to evolve and monitor the situation. At the same time, other notifications have gone off. If you look at my notification list, there was the emergency evacuation alert that went to those individuals who were within the immediate vicinity on the map. And for those individuals who did not reply and get to safety, it sent emergency crews notification as to where their whereabouts are so that emergency crews would know where to effectively help people. Effectively, these 3 people are still in the environment. They have not left. And that's why the system continues to send out those notifications. This is what it means to be situationally aware and provide real-time context and understanding of those situations, as well as the ability to iterate until you get to the best possible business mission outcome, et cetera. And I think I'll wrap up the demonstration there. And of course, if you have any questions, please let me know.
Thank you so much. That was a spectacular layout of what you're currently doing. We'd like to take that information and apply it to joint all domain command and control, and how we can utilize this in various medical scenarios, soldier lethality, and then being able to sustain all of those situations for the Department of Defense. So if you can tell by his presentation, this is all built around what can be utilized in the Department of Defense as mosaic warfare. That is the driving factor of adaptability in joint all domain command and control, and the combined situation that includes our allied forces around the world. This shift in focus on lethality at the tactical edge, layered to the echelon level, will be the dominant theme of the future integrated battlefield. These systems allow for levels of communication and orchestration that provide situational overmatch and real-time adaptability unlike any other time in human history. Being able to help other countries prepare for JADC2 in their own region will make them a stronger and more prepared partner for the United States and for any near-peer conflicts. We are dedicated to merging lethality, survivability, and sustainability into one smooth software platform designed for human flow and left-of-bang pre-programmed protocol. This allows for the most chaotic situations to be assessed, organized, and executed around in unparalleled fashion. We refer to this as sense, make sense, and act. Jim, do you care to go over like a 30,000-foot view of Vantiq and how this is applied to joint all domain command and control, sir?
Thanks, Jordan. Yeah, so what I'll do is I'll just spend a few seconds on some slides that give people some additional context about JADC2. This is from a briefing that I gave to the Pentagon back in midsummer here in the States. JADC2, Joint All-Domain Command and Control, is a framework that not everybody's familiar with. It was developed by the DoD to connect sensors and shooters across all 5 domains of warfare: land, sea, air, space, and cyber, into a single unified network. And this network would allow for this seamless sharing of information and decision-making across different branches of the military, thus enabling them to operate more effectively and efficiently in a more complex and contested operational environment. So JADC2 is still in its early stages of development, but it is considered to be a critical component of the DoD's future warfighting strategy. You can just look at all the conferences and keynotes that are happening and how JADC2 is always a hot topic. The DoD is currently working on a number of initiatives to develop and implement these capabilities for JADC2, or CJADC2, the C meaning combined, to include coalition partners and other mission partner environment colleagues for the U.S. And so the development of these new technologies, the creation of this organizational structure, and the establishment of these procedures is, at the forefront of what's happening. So very quick, I'm going to touch on some things. I'm not going to repeat what Brett already said about sense, analyze, and act. But I did put together a slide from that Pentagon briefing that leverages the concepts of the architecture for JADC2. And the challenge, as is highlighted here on this slide, is that sensing is getting the data in from all the different domains. Making sense is working from an analytics perspective to include AI and generative AI. And acting is to basically engage people, processes, and systems and authorities to cause those outcomes. The challenge is, how do you effectively integrate the data, the intelligence, and orchestrate that effective human involvement and machine and automation across an integrated and agile architecture? So very quickly, we believe that Vantiq is in a great position to assist, given what you just saw. In particular, there are challenges on the sensing side, interoperability, bandwidth, heterogeneous data. So we have a very strong statement on and capability for how to bring the data in. The making sense, again, you want to have understanding of the environment, not only your own understanding of your own systems, but those mission partners that are plugging in. And how do you provide that in a edge environment with reliability, leveraging embedded AI and other tools that provide that context, and then making a suite of solutions that can mesh all of that together. And then finally, on the ACT, we're going to have a mechanism where it's not just machine to machine, but also human to machine, human in the loop, human on the loop. And of course, then there's the complexities of cross-domain, both from a silo to silo, as well as cross-domain from unclass to class and specialized enclaves. Finally, what makes this really a challenge is the agility aspects. Because these systems have been built over many years and by many different stakeholders, they don't necessarily plug and play together. So how do you bring this agility of DevOps in integrating all these different systems together in order to provide this hyper agile platform? And so Vantiq, we believe, is in a phenomenal position to assist with that. So with that, I think that's a pretty high level 30,000-foot view. Jordon,
Yes, sir.
where would you like to go next?
So just real quick, and we'll close this meeting up. I want to be able to cover the practical application of this for the military. And so we really focus on the make sense and act portion of your capabilities. Obviously, you all have a strong software architecture in order to create these types of situations. And now I'd like to kind of discuss how this is applicable in medical and human performance and other areas. So I know that with the medical world, we believe that human performance optimization combined with point of care medical capabilities use similar data points. The difference is the subject matter experts applying the data to various situations. For instance, the data utilized by a tactical strength and conditioning coach to increase rate of force development and prevent injuries or even optimize nutrition would be different than the combat medic that would use it for triage or medical dosages or even point of care equipment resupply. So there's an area where we're going to have to be able to detect multiple biometric data points, and then we also got to be able to utilize those for various situations. John, would you like to break down your view of how to utilize this software in order to apply yourself even better at the tactical edge, sir?
Absolutely. So before we get to the actual operator, themselves, I'd like to start off with the Vantiq and the combination of this data in real time has such an immediate capability for not only surveillance, but for increasing survivability of the task force as a whole. Reason being is many times, medics have to go out to see different hospitals in an area for multiple different reasons. But you can obviously see how many people a normal census of the hospital would be occupied by this information. You could also see when there's heightened areas of hospital usage because of the more patients are there. This would also allow you to see whether or not a hospital is not being used. And in a mosaic warfare environment, if a hospital has been abandoned because of danger, it could be also occupied and utilized by friendly forces as a hospital. And therefore, it now becomes a building of opportunity that has fully kitted out and just needs the augmentation of our personnel to be able to staff it. Secondarily, we can look at radiation levels, as was pointed out earlier. And where radiation comes into play is it allows us to say what that capability of that hospital is. What it also allows us to do, and this is something that was seen in Haiti when the earthquake happened, several MRI machines, X-ray machines were destroyed. Well, that is still radioactive material, and it poses a threat. So therefore, it's not only a threat within the area that it's housed in or put in, but it's also a threat if someone was to take that, put it on the black market and sell it. This type of technology would allow us to track the radiation as it left and where it was being taken, whether it was going to be disposed of, whether it was going to go on the black market, because essentially some of these components could be used to assemble a dirty bomb. One of the other aspects of this system is that when we look at the amount of casualties in an area, this can allow us to see who's mobile, who's not mobile. This can also allow us to predict how many people are in the target area. We already know the number of our force and how many total casualties were sustained. This can also let us know if we have any CBRN weapons being utilized. We'll be able to detect, as was stated earlier, the leak from the type of munition, as well as the fact that what direction of people would be exposed. Now, for energy weapons, what this would allow us to do is be able to see whether the energy is bouncing off certain structures and which ones it's actually penetrating, which could end up allowing our directing our task force to take shelter within a specific building that is not being penetrated by the directed energy. And with current advances in directed energy weapons, you can have anything from neurologic disruption to instantaneous cellular death. So this increases survivability immensely. Now, let me get into the aspect of the human performance. In a training environment, it is the hardest thing to try to really simulate combat. However, through repetition, we can go ahead and increase resiliency. And so therefore, we can monitor through biometrics, different individuals' heart rate, their decision-making capability. And when we introduce unsuspected stimulus, where does our heart rate go? Are they still able to operate at that same level? There's a saying that is very true, that people don't rise to the level of their training. They fall to the level of their muscle memory. So the closest thing that we can do to build the resiliency for them to stay on task and not interrupt the tactical operation, whether the tactical operation calls for medicine or breach, is to consistently overstimulate and to give unsuspecting stimuli, so that way it does build the resiliency and they do have the confidence in themselves. As this relates to physical fitness, with each different training iteration that people go through, as the breach or the what the mission calls for, going upstairs, conducting several different operations, will tell us the physical fitness requirements of those types of operations. And we can further assess whether someone is primed to go on mission by utilizing various means of physical fitness tests, but also through biometrics and heart rate variability, to see whether or not the individuals on the team have gotten enough sleep, whether they've gotten enough nutrition, whether they're at the optimal condition to sustain this mission, not only for the mission itself, but also if the mission was to go sideways and they had to rely on an extended period of time. Software will also tell us whether or not the environment has a play in it: extreme cold, altitude, extreme heat, and it would allow us to go ahead and accurately predict through an algorithm the ability for each operator, depending on where they are at currently, whether they are the best individual for those specific missions. At the same time, we've seen this in the past with military working dogs that have come out of Washington State, but yet were put in Iraq and they couldn't handle the weather change. But this also happens with humans. Humans are easily more adaptable. However, it still does have an effect. And any type of edge that you can have that will allow and increase the survivability of our force is a great attribute for sustainment of the combat power. It takes a long time to be able to produce these individuals. This would also allow us to predict the medical need, especially in a mosaic and contested logistic environment. This would also allow us to identify logistical hubs within the country that we're working in, that we could procure specific medical devices or bandages or whatever else we needed, because of the fact that we can tell where specific things are. This would also allow us to look for the best locations that are less populated for us to be able to have surveillance or have a pickup site. But specifically with the human body itself, once sustained injury, this would allow us to be able to help send forward medical assets, divert medical assets, hold back medical assets, and make basically overall good medical decisions as to where to best utilize limited resources with air assets, maritime assets, or even ground assets. This would also allow us to be able to monitor the basic chance of survival for many of these casualties and the severity. Whether it's an IED, burn, and whatnot, we would be able to see in real time and understand that if, as we send things out, what extra supplies might be needed, what other special equipment might be needed for the extraction of these and evacuation of these casualties, how far they could fly without putting them in a position where we lose the advantage of being able to prevent death.
Oh, that's incredible. So, in addition to first of all, if you can't tell, we can pretty much use Vantiq to solve any issue if you can apply it within the coding. And we have protocol by gentlemen like yourself and others that have created the ability to respond to these situations properly. And all we need to do is be able to activate those faster on the edge. So utilizing like LLMs that can push TCCC and March protocol to individuals that may be sustaining a traumatic brain injury or something of that effect that causes them to lose some capability in the moment, but being able to let them access certain information in real time can jog their memory or allow them to perform better. Do you mind to elaborate on that one moment, and then we can close everything out?
Absolutely. And I'll use a personal experience. In 2007, I was in a vehicle and we had hit an IED. Everyone was able to get out of the vehicle. We had some people had sustained some minor injuries. Almost all of us had a mild traumatic brain injury. I had to treat one of my my team sergeant, and he had some fragmentation in his arm. I applied a tourniquet. I knew that the ratio was for lidocaine was 5 milligrams per kilogram. However, I had lost higher brain function. I could not do simple math. Luckily for me, I always kept a card for my team to be able to treat me. And because my team sergeant weighed about 30 pounds more than me, I knew that I could actively use my card on him without causing any damage. It took me about 2 days to be able to get my higher brain function back. But being able to have something that pops up on my watch or phone or some type of other medium to be able to take place of that 3x5 card that I had would have been extremely useful, especially if it was a complex casualty and I had to institute polypharmacy in order to stabilize and evacuate that individual. So this system will allow that interface, and with protocols and guidelines, allows them to stay within those parameters, and will also make them feel comfortable when they've got to step outside of those parameters, because they know that they're talking to someone else that is giving them the guidance to step outside those parameters, which affects the psychological capability and resiliency of the medical personnel on the ground. Because one of the things that most people end up feeling with PTSD is a sense of guilt. Could I have done more? Did I do the right thing? Did I follow the right protocol? And if I had to step outside that protocol, was it the right choice? And your only measure of your success is whether or not your patient lives or does not live. So this would also alleviate that guilt that many people carry with them and allows them to see that they did do the right thing. They did have somebody watching over them, and they did have the most accurate real-time information to be able to treat that individual.
Amazing. The software architecture that's utilized in this and many other medical scenarios can be applied to soldier lethality in a variety of ways as well. First, in one-on-one advanced like human machine teaming and interface, this allows for an operator to have one-on-one real-time control of any robotic asset via soldier-centric design. And then this, due to its unique feature, can be scaled for goal-based autonomy, or we refer to as configurative swarms. This means that our JADC2 software can communicate to different outcomes to different assets at the same time, either by left of brain pre-programmed protocol or real-time adaptive response to edge data. And this is very important because that means that we can take various robots and drones, ground-based robots, sensor data, radios, whatever, and create a configurative outcome that has different end goals, but all work together at the same time. Whereas a normal swarm is all based off of the same outcome to the same geolocation for the same job. We can actually do multiple jobs at the same time, so therefore increase overmatch on the tactical edge. And this gets into sustainability of both situations, because you have to sustain the medical end for point of care and survivability to have operators that are usable and functional. And then you also have to be able to sustain soldier lethality as well. All of these examples require sustainability to maintain functionality. The understanding of our protocol allows us to streamline the equipment and other requirements for supporting operations. This is applicable to beans, bullets, band-aids, blood, body, bombs, buddies, and more. So are there any comments or any points that anyone would like to make on how we can use this for various situations before we close out? I don't want to spend too much time before we can have follow-up meetings with individuals.
One other thing I'd like to add is that because of this, the way that the system works, this would allow and increase the ability of education for your command, your staff, your medical officers as they're going through their basic courses, and they would learn off of real-time executed missions that have happened before and be able to gain the experience that people experience for the first time as they were conducting the operation. You can always teach didactics out of a book, but when you teach from real-world experience, that is the hardest thing to capture, because right now there is not a system in place to be able to see the entire battlefield, the entire operation, the way that this software allows you to.
Very, very good point. Just to recap, Vantiq is the connective tissue holding JADC2 together and allows for the transfer of critical information in the proper format for seamless activation and coordination of assets for any operation. This is true for small unit special operations all the way to echelon level interdepartmental, interagency, and international interoperability. Without any language barriers, both human and robotic, the future is interoperable and collaborative. Vantiq enables the future today. Jim, would you like to add any points to close out on Vantiq's behalf, sir?
I think I'll save follow-up dialogues with folks who are interested. But in closing, I would just say we have very compelling stories of integrating systems we've never seen before in very short periods of time, like hours, days, and have an operational system up. So I look forward to the follow-ons.
Yes, sir. Any entities or organizations interested in our capabilities, please contact one of the professionals represented in this video via LinkedIn, and we will coordinate a path forward that can include an 8A contract vehicle, IDIQ options, or numerous other ways to ensure situational overmatch anywhere, anytime. We appreciate your attention today, and if you have any questions or any comments, please feel free to contact us. Thank you so much.